This is a graph of measurements, two different ones, they're on the same graph, that show ionizing, cosmic radiation, etc. due to altitude from 2 to 8 kilometers going left to right. And as you go up higher, you get the very, very nice little curve there from, let's say, 15 ion pairs per cubic centimeter to upwards of 100 higher up. And that's only 8 kilometers. Altitude in kilometers over here, ion pairs done a different way using a chamber to test it. I'm pretty sure it's a cloud chamber. The point is you get a sudden increase at about 4 kilometers, depending on how you're measuring it. Now, here's the hourly count rate varying from around 340 to 420, make a joke, over a period of time from looks like 1953 through the year 2000, and I'm thinking 6 here. Okay, place your bets. Does that line up the cosmic ray count? And where was this taken from? I know it's really hidden at the top edge there. What a name for a town in Colorado. Anyway, what was the average cosmic ray count variation timing? You may have noticed that, well, if you see a dip or a weirdness in there that doesn't match the sun, that's because the magnetic field of the Earth is messing with it. Okay. It's that time of the year again, huh? Okay. 1970 through 1982 are the low points. And then it's 1959 through 1970 for the previous one. 1990 through the year 2000, almost exactly, on the next troughs. And then the wacky thing that happened in 2001, excuse me, Space Odyssey. A lot like the little wackiness that happened in 1974. Must have been gas prices. And that's a variation. Is that the 35% variation? Okay. I'm exploring the 35% rule here. These are neutron monitorings. Not cosmic rays, but neutrons. You can have neutrons, protons, electrons, cosmic rays. Okay, here's your cycling here. Now this is going to match the 11-year cycle, right? Pretty close. Those are the minimums right there. Solar cycles, right? What happened in 1991 that caused it to almost hit negative 25 percentile? This is percentile, by the way. Over the average, or under the average. What happened? That's actually worth exploring. I want Warble Garble to cover that. This is the heliosheath or whatever. This is the emission of stuff from the sun. Now I want to point out a couple of things here. The electromagnetic effects of the sun being a magnet and having a lot of variations around every 11 years means that it creates this sort of spirograph of behavior that swings out in space almost exactly like that. The stuff in the middle upper area was pointed that way and just kept going out. We're just seeing it going out. And as it goes out, that electromagnetic field goes out at the speed of light. So it takes mere hours for the magnetic and electrical effects and some subatomic particles to travel unimpeded through the vast wastes of nothing in space that you get out into space. And according to this artist's rendition, it has a lot of physical variation in polarity as it radiates. Tiny variations create big variations at a distance in mere hours or days. How fast does the material itself from the solar wind actually move? Well, that's been listed. It doesn't travel the speed of light. And there's a fast and slow solar wind. So you have stuff moving at the speed of light, which is electromagnetic in nature, and photons. You have subatomic particles that go nearly that speed, but eventually do slow down. And you have material going off at much, much lower speed, taking upwards of decades to get out that far. You already knew where I was going to go with this, but this is a little wrinkle, pun intended, on the idea. So here we have the sun, earth, moon, Mars, yada yada, your mom. Then we have the termination shock, heliopause, that's where the speed from the sun's material runs into the interstellar medium and stops. This is on the front edge there. This is backwards from the other diagrams I'm going to show you. And you have the bow shock where all the termination velocity and heliopause stuff all culminates in chaos. And that's out by the Kuiper belt, and there's supposed to be a hydrogen wall out there. Okay, and I like that they included Pluto. This is an old one. Now this is the basis for the heliosphere existence. You may have noticed something, the distance, right? I said it would take hours or days for electromagnetic material and information and effects. Weeks. But it would definitely take years for material to get out there. Yeah, you knew this was going to happen, didn't you? So, when you measured that information, was it from the Voyager probe you got that 35% drop? Because the Voyager 1 probe exited the terminal shock and there was a sudden increase or decrease in various things. There's the bow shock of our whole solar system ramming in, and it creates a sort of a plasma halo. The heliosphere is asymmetrical. It's drawn out in a teardrop shape, correct? Okay, I'm going to point out a couple of things here. That's way far away from us. The accumulation of material that make up the edge of the heliosheath at the heliopause and heliosphere, that bubble we're wrapped in that you were specifying dropped or increased by 35%, is a cumulative effect over decades of material buildup. That's why it's doing this. And by the way, I'm going to point out something about the shape of this in a minute. But again, having a variation in a 5-year period of time is not going to change much in something that takes millennia to change. The heliosphere around our solar system probably doesn't change very fast because it can't, because it's the effect of material buildup mostly, not magnetic or electrical changes. The electromagnetic field, and therefore magnetic field, of the sun cannot propagate that rapidly. So you'd have to show a change now as being caused by something that happened to the sun decades ago, because that's real. If you want to make it instantaneous, it can't be either. You'd have to at minimum say it takes several hours or days. And again, you have several variables. You have a fast solar wind and a slow solar wind. So they're going to have different timings. You'd have to find a timing coincidence that would cause it to somehow become stronger or weaker for your claim of it being reduced by 35% to make any sense. And now I'm going to bring up the next thing. There's the Voyager probe data showing a 1.6 to 1.9 change. Was that what you're referring to? Now, if Warble Garble, if you're watching this, pause the video because I have something to show you. That's the actual shape of the damn heliosphere. Yeah, 2015 they updated the model for it and found out that they were wrong because they could measure it using, as a reference point, the position of the Voyager probe. We were wrong about the shape of the thing, so now you have more dynamics. I mean, seriously, it looks like a 60s hairdo kind of thing, purple hazed. No, it wouldn't. The cumulative effect of all of those things at once would not happen within plus or minus even a couple of weeks to cause the changes you're seeing, maybe even years. By the time you see a change in the solar cycle, the cumulative effects in the heliosphere would nullify it and average it out. Solar energetic particles and events and coronal mass ejections effect on the Earth are moderated by the magnetic field of the Earth primarily, if not entirely. Because, in case you didn't notice it, your compass needle doesn't change every 11 years. Because it doesn't. Next, variations in solar activity producing material simply adds to the layer, a cumulative effect I might add, to our own sun, our own Earth's magnetic shielding that we have there. And galactic cosmic rays, galactic northern rays and galactic southern rays, are stopped by it primarily because they still get past the sun. But all of these layers have the effect of reducing it, and then it hits the atmosphere. And claiming that it's going to cause rain clouds to form is a little stupid because even that gets averaged out. Interplanetary magnetic field lines from the sun run into the electromagnetic bow shock of the Earth, and they get warped by it, not the other way around most of the time. I mean, there is variation, but the dominant effect on the Earth is the Earth's magnetic field, hence the reason compasses don't have to be changed every 11 years. This is the magnetic field of what? It's changing over what period of time from 8.3, let's call it, to 7.8. Okay, is that your 35% reduction? What about this one? This is a little bit more scintillating. 61,000 down to 54,000. From 1900 to 2000. So that's 100 years of variation with a stable period, we'll call it, at 57,000 from, we're going to call it 1940s through the 1970s. I mean, it's not like it's clearly labeled what magnetic field it refers to. You may have noticed it doesn't have the cycling you're talking about. And it's the dominant characteristic for this. How about this one? This is estimated based on other proxy data. I guess 1776 was some sort of cosmic year. By the way, the graphs that are shown on religious sites show this only peaking at Christ's birth. I just thought I'd throw that under the bus. Axial dipole strength, the dipole strength of the Earth, versus incidental magnetic fields in your area. Milankovitch cycles are based on mixing the different waveforms that you have when you look at things and getting some data out of it. And then we're supposed to compare it to from 0 to 800,000 years ago, less than 1 million, it's showing some effect on climate change. Well, the climate data is right there. There's two different sources, the Vostok ice scores and Benefic forums, and they don't match any of it. It's dead. But hey, you can show modulation of one thing by another, but they don't correspond with atmospheric or environmental effects. But you can always pull out a MacGuffin out of your butt and say, well, the dinosaurs did it, or some other blasted thing, right? And last and most importantly, the actual speed of the solar wind over a 24-hour period of time, 600 kilometers per second down to 350 kilometers a second. That's a little bit more than 35% change. Are we talking averages over several years? Where's your data? Where's your rationale for this? For a 24-hour period of time, yes, the website actually says this, 600 to 350 for the solar wind. Obviously, a 2-to-1 ratio is a little bit bigger than 35. And it happened over a one-day period of time? No, it's 24 hours, not 12. Remember what a day is. Thanks for watching. Have a good day. Good luck with all that.